So this one's a little bit more difficult because we have an x minus 1 here, and you should be familiar with what that integrates into. But obviously we need to integrate the whole equation or the function, and then we're going to bound it by 3 and 1. So that's basically on the x-axis 2 vertical lines saying 3 and 1, and we're looking at a segment underneath a squiggly graph and looking at whatever the area is underneath that. So let's first integrate this. So the integral of 2x cubed plus 3x minus 1 plus 4x squared, is with 3 and 1 here, all with respect to dx. Proper notation is really important, especially at school level. I think when you get to university level, there's an expectation that you know how to integrate. So we're going to have 2x 4 over 4 plus, this is going to become ln x, 1 over x integrated is 3 ln x, plus 4 over 3x cubed plus c. And obviously this is all bounded by 3 and 1. So let's plug in. What you do is you plug in all of these terms. You can kind of forget the constant for now, the value of 3, and you subtract that from all of these terms when substituted in for 1 from each other. So the area is then going to be, I'm going to also, that should obviously be a half. So that's going to be 3 over 2 power of 4, 3 ln 3 plus 4 over 3, 3 cubed, minus, it's going to be 1 over 2, 4, plus 3 ln 1, because that's what we're substituting in, plus 4 over 3, 1 cubed. And that is pretty obvious. You don't really need to use a calculator for that. Is going to be a equals 76.5 plus 3 ln 3 minus 11 over 6. And then if you can just quickly do that in your head, a is roughly going to be 77.9628 square units. So that is how you find the area under the graph. Integrate, substitute in the values, whatever the greater number is, minus whatever the lower number is, and you found out what the area is under the graph, under that bounded area.